Welcome to question 5 of the Year 12 PPE. This question, when you first look at it, appears to be about the sine and cosine rule. Okay, so I've just read through the question and added some of that information onto the diagram, so it's always worth doing that. So I put the 14 here, the 2 8s, meaning that this is a small isosceles triangle. Diagram not to scale. So just be wary of that, because it may not quite appear as it should do. And we've got to find to 1 decimal place the size of angle ACB, which I'm going to call theta. That's this angle in here. Okay. Now, we just need to be careful here, and you'll see why in a moment. So according to the sine rule, I know that sine theta over 14, okay, sine theta over 14, I'll put here question A. Okay, so sine theta over 14 should equal sine of 27 over 8. Okay, and if I rearrange that, that gives me sine theta equals 14 sine 27, and that has to be over 8. Okay, so that's the normal process that we would follow up to this point, and then take the inverse sine, and it gives me that theta equals 52.6. okay. Now at this point, just pause and notice that theta certainly appears to be an obtuse angle, and this is the smaller angle here. Now that's significant because you see, when you do the inverse sine of something, it will give you what we call the primary value, the principal value, the one closest to 0 degrees, okay, which is 52.6. Now this is a graph of the sine curve between 0 and 180 degrees, okay, just a sketch of it. And we've done this. We found a value which leads us to find this 52.6. Okay, but what we've actually found is this one here, 52.6. Okay, but there's another solution below 180, which is this one here. Okay, so this one here is the one we're interested in, which is the obtuse angle, and that comes from 180 minus 52.6, okay, which is the one we want. So I've given 2 possible values of theta, and of course there are many more because the sine curve continues, but these would be the ones we would be interested in, and in particular the second one. So theta greater than, so I can just say that theta greater than 90, therefore theta equals, now it's going to be that calculation which comes to 127.4 degrees to 1 decimal place, which is what we were asked to give. Okay, so just be wary of that, and use the diagram in conjunction with your calculations. Now that takes us on to question B, and in question B, okay, let's do that down here. We are asked to find the minimum length of steel that needs to be bought to make the complete structure. Okay, and the steel can only be sold in whole meter lengths. Well, first of all, we need to work out the total length of the structure. So I'm going to use the cosine rule here, and I'm going to find the length of the line AD. Okay, so using the cosine rule, I've got that AD squared, okay, is equal to 14 squared plus 8 squared, okay, minus 2 times 14 times 8 times the cosine of the angle between them. Now, the cosine of the angle between them is 180 minus the 27 and minus the 52.6. Now I'll just explain where that's all come from. This is 52.6 because of the way in which we calculated theta earlier, all right, here. And because that's 52.6 and this is an isosceles triangle, this angle here is also 52.6. Okay? So the angle I'm using in my cosine rule, which is this one here, okay, if I just call that angle there maybe beta, okay, that's probably going to be clearer. Okay, so I'm just going to put here cos beta, okay, and the cos of beta is, is 180 minus 27 minus 52.6. Okay, so that is equal to 14 squared plus 8 squared minus 2 times 14 times 8 times the cos of 180 minus 27 minus 52.6. Okay, and just make sure, of course, the calculator is set to degrees when you're working with this. Okay, so if you put that in, that gives you that AD equals the square root of that, so that would give you AD squared, and so AD equals, and it comes to 17.333. Okay, now that's not 17.3 recurring, it just happens to be that to 3 decimal places. Okay, and so the total length of the beams are, so if we could just maybe move across here, total length of beams is going to be equal to, well, you've got a 14, okay, you've got an 8, you've got another 8, and you've got this 17.33, okay, and that comes to 47.333. Okay, now you would be tempted in the first instance to round that to 47, but of course steel has to be bought in 1 meter lengths, so therefore 48 beams needed, 48 meter beams needed. Okay, and that would be the answer to the question. Okay, so it's using sine and cosine rule, but just taking into account this extra complication with the obtuse and acute angle situation we discussed earlier. Okay.